All right. Nice to see you all here. Good morning to everyone. So I am Karlis. I'm the Customer Care and Mechatronics Product Business Manager for Dinex. And today I'd like to speak to you a little about NOx sensors. Then as usual, we know that this is a little bit problematic product group. It has given us all quite a bit of headache, but we are working hard and working to overcome these issues. And today my job is to introduce, to show all of the possible links that affect the NOx sensor's life and to discuss what we have done about it. So let's see if anyone else is joining. So far, it seems like nobody else is popping in. Then let me share my presentation. Can you see it? Okay, thumbs up. Good. We have another guest at meeting. All right, so let's see what kind of topics we shall cover today. Let me put that on full screen. So first of all, we're going to look at some typical failures that we usually get from the quality claims. Then I'll also speak a little bit about cross-referencing and particularly why the continental number is important. I will also go into a little bit more detail explaining the importance of maintaining the engine and exhaust system and how that affects the NOx sensor. And then lastly, we will go over the latest improvements to our latest generation NOx sensor to see how it has evolved over time. So let's begin. And also a little forward, perhaps if you feel that you have any questions, please feel free to interrupt me. I always prefer to have a productive dialogue rather than a boring monologue. So on that note, we can begin. So in general, this is the schematic layout of the modern aftertreatment system as we know it today. And for the US market, that would be the EPA 17, and of course the EPA 10 is a lot similar. And what we can instantly see from this is that it is complex as it gets. So it's not just the hardware. We also have a lot of emission-related technology, such as the particulate filters, the oxidation catalysts. Yeah, I can hear somebody still trying to get in. Let me admit them quickly. Right, admitting. Going back to full screen. So yeah, this is the modern aftertreatment system. It has emission components such as sorry guys, I need to keep admitting people to this meeting. Right. Okay. Modern emission components such as the particulate filters, oxidation catalysts, SCR catalysts, plus we get all the mechatronics components, the sensors such as delta pressure, the temperature, the NOx sensor. We get two injectors. One is for the DEF, the other one is for engine fuel. We get a pump, a control unit, a tank, a heater. So basically all that you can imagine goes into a modern aftertreatment system. So that is, nowadays it has become a very, very complex system, and many things can go wrong, and most of these things are interlinked. But looking back at the NOx sensor, the main job of the NOx sensor in this system is to measure the difference of NOx concentration before and after the catalyst. And why is that? That's because the catalyst is there to take care of nitric oxide emissions. That is its sole purpose is to simply reduce NOx emissions. The catalyst can only do that if we are injecting DEF and mixing that with the exhaust gas. If we do not inject any DEF, no nitric oxide emissions can be taken care of, which means that the system is not functional. And so the NOx sensors are therefore usually two. One of them sits before the SCR catalyst, the other one sits after the SCR catalyst. And what's also important is that the NOx sensor is what's considered a smart sensor. And a smart sensor means that the sensor is able to do its own communication. It almost speaks, if you will. And it's communicating all the time with the engine control unit. And the communication is being done according to some standardized protocol, the J1939. But basically what I want you to understand is that these sensors come equipped with their own little computers. They have their own little language or programming inside them, and that is used to communicate with the ECU. And I will just explain in a second where it gets even more important. Just a second. Okay. So first of all, let's look at all the typical failures that we are getting. And from the quality claim analysis that we have done so far, we can see that we have two immediate conditions. Either the NOx sensor is not working immediately after installation, or it stops working after a very short distance. And on the right-hand side, you can see all of the occurrences that are associated with these issues. But please keep in mind that these occurrences are listed only for the quality claims that we have received. So we do not have 100% faulty production. Okay, and firstly, if the sensor stops working immediately after installation, we have three most likely culprits for that. Number one is incorrect cross-referencing. Number two is incorrectly performed sensor diagnostics or misinterpreted results. Number three, and why it's colored in red, is incompatible software. So this is our fault, and this is something that we need to acknowledge and fix. If the sensor stops working after a short distance, the three likely culprits are poor quality of installation works, about 10% occurrence, and poor condition of engine or exhaust system. Now this is substantial. That is 20% occurrence that we see as the driver for NOx sensor failing after a short distance. And of course, lastly, no product is perfect. We do have a certain fallout rates for NOx sensors based on actual quality issues. At this time, it constitutes roughly 5% of all the claims that we are getting. And so a little bit more about the programming and the importance of the continental number. So a second, need to let some more people in. Okay. So we all know that Continental is a big company, and they are the original manufacturer of NOx sensors. And they are then supplying all the different truck manufacturer brands across the world with their own product. And where it gets important is that Continental, since they are the original manufacturer of these sensors, they get to decide what kind of programming shall be used inside the sensor. Now, as an aftermarket supplier, we are only attempting to replicate it. And here we must be very careful in the ways how we replicate the programming, because it is very easy to do that incorrectly and very easy to fail. So this is quite important. The continental number that you can find on the backside of the sensor is what actually determines the programming used inside the sensor. And we have seen that there's not just a few different kinds of programming in the sensor. There is a specified programming for each and every product. So if you take, let's say, a Volvo sensor, then that will have a different programming than basically between the makes, there will be different programming, and between the models of the trucks, there will also be different programming. So it is extremely important to actually choose the continental reference correctly. Otherwise, we are risking a condition where the NOx sensor will not communicate with the ECU simply because it's being asked something that it has no reply to. And therefore, we will get an error message stating that there is no communication with NOx sensor and it must be exchanged. Okay. We will return to this topic a little bit later, but for now, there is also the condition where we know that people are performing the diagnostics on these sensors to find out indeed if they are failing or not. And what we have seen is that in quite a few cases, the diagnostics that are performed on these sensors are being carried out incorrectly. And what do I mean by that? The NOx sensor, in order to operate, it must reach a temperature of 800 degrees Celsius. I apologize terribly because I do not know off the top of my head what is that in Fahrenheit. But at that point, when the temperature is reached, the NOx sensor chip is glowing red hot. So it's quite substantial. And it is important that not only the NOx sensor has reached the operating temperature, but also the exhaust system. Because the exhaust system, when fully heated, the SCR catalysts can finally start to operate. If they are still cold, then no DEF will be injected and no NOx conversion will take place. So a cold system is a non-functional system. When we do these diagnostics, it is extremely important we give sufficient amount of time to warm up firstly the engine so that it can start to operate under the emissions regulations norms. And then we must give some more time for the exhaust system to warm up because then the catalyst can finally start to operate. And only then we can try to diagnose issues with NOx sensors. It is when the actual NOx conversion is taking place. It is when the actual measurement is taking place and everything is as it should be. So yeah, with this, I would like to give the message, please do not rush to conclusions when doing NOx sensor diagnostics. Please make sure that everything is brought up to operating temperature between doing any diagnostics. Okay. Moving forward. Another issue that we have seen is poor quality of the installation works. And one example we can see on the top right-hand side. There we have evidence of a stripped thread. And why is this important? Well, I hope some of you have actually tried to remove a NOx sensor or a lambda sensor that has been sitting inside a system for quite some time. It is not that straightforward. It is not easy. When you try to do that, you will most likely need the longest possible wrench that you can find, because these probes cook into the bushings real bad, and it takes substantial amount of force to actually remove them. And in that process of removing them with excessive amounts of force, we will most likely damage the thread. And when replacing the NOx sensor, please keep in mind you are replacing something that is brand new out of the box. Well, it's a brand new, nice looking nut that you are trying to install into a bushing or a nest that has been just destroyed by a, well, let's say 10-foot long wrench, right? Obviously, you will see that in many cases, it will not want to go all the way in, and you will have to use another 10-foot long wrench to get the new sensor in as well. And why is that a problem? Well, the sensor, actually inside of this probe, there is a ceramic chip that is made from zirconia electrolyte ceramics. And that stuff is extremely hard and it's extremely brittle. And that means whenever we are using excessive amount of force or if we are shocking the sensor, we have a high likelihood that these ceramics will crack. And so whenever somebody's been trying to screw in the sensor with an amount of force that causes this thread to actually strip, we know for sure that the sensor probe has gone under some considerable stress and the ceramic element is most likely gone. So this is important to keep in mind that the thread should always be cleaned and retapped before installing a new sensor, especially when it took considerable amount of force to actually remove it. Then we have also seen some evidence of damaged wire insulation. well, this might not look serious at first glance, but it does become a problem after a certain period of usage, because whenever the insulation is damaged, we are allowing moisture inside, we are allowing dust inside, and this sensor is exposed to a lot of heat, a lot of vibration, a lot of debris. All that stuff gets sucked into the cabling right here under the insulation, and under prolonged exposure to vibration within a dusty and moist environment, the wire insulation will fail and we will have a short circuit or an open circuit, and we do not need to guess what will happen as a result of that. And we've also seen some cases where the mechanics who are doing the actual replacement of the NOx sensor will take they will spend poor attention to routing the wire harness correctly around the silencer. They will fix it very in questionable manners, and they will basically be the job will be very sloppy and poor. And why is that important? That's important because, again, we are dealing with a very humid, very hot and vibrating environment, where if something or some sections of the wire harness are routed incorrectly, then that can have a terrible impact when exposed to vibration and dust. And usually what we see is that these wire insulations will fail as a result of rubbing against some parts of the silencer or the frame where they shouldn't be, and eventually damaging the insulation, creating a short circuit or an open circuit, and resulting in a failure of a NOx sensor. Yeah, and lastly, on this slide, I would like to mention that it is also important to carry out a NOx sensor replacement according to the manufacturer's manual of the vehicle. Moving forward. And of course, as I mentioned already briefly, no NOx sensor, or no product for that matter, is perfect. We certainly have a fallout rate also associated to actual failures. So that would be that the chip is sometimes cracking prematurely because of some production batch issues. We could also see that the backside cover of the sensor is not sealed completely. So that will allow some moisture to get in to form some condensate. That condensate will then form oxidation signs, and oxidation will ruin the electrical connections and the sensor will open or short circuit. So all of these are known issues that we acknowledge. That's why we have the warranty return procedure in place. And now a little bit to the perhaps one of the most painful topics. And to begin with these, I would like to state that the NOx sensor is very problematic, not for the reason that the design of the sensor is bad, not for the reason that the quality of the sensor is bad, and not for the reason that sensor is just a sloppy part. It is not. It is simply the conditions that the sensor lives in that are extremely rough, extremely aggressive, and it is the construction and measurement method of the sensor itself that is extremely sensitive to contamination. And as it turns out, whenever these systems have been driven for quite some miles, then we will get an increased likelihood that contamination might be present in the system in one way or another. And the first of these contaminations is the engine oil. The most likely culprit usually for the engine oil contamination would be the failed turbo oil seals. And these oil seals will very often fail because the bearings have failed. And as a result, where the bearing is allowing increased vibration of the impeller, the oil seal can no longer compensate the movement, and the oil pressure will escape under the oil seal and into the exhaust system near the impeller blade. And the result of that will be that it will find its way to deposit on top of the DPF substrate. That substrate will then get clogged with engine oil very quickly. It will be blocked, the back pressure levels will be increased, and all that pressure has to go some way, and it will break a hole to get there. And as a result, we see that the DPF is usually breaks as a result of overfilling with either soot or clogging with engine oil. And the result of that will be that we now have not only engine oil contamination, but now we have soot contamination. So particulate matter is allowed to get to places where it shouldn't normally be. Also, in some cases, if you are not very lucky, the engine oil will actually combust in the high temperature. And the result of that will be that you will have a melted oxidation catalyst, melted DPF, and as a result, all of the issues that I mentioned already before. And yeah, the impact on the NOx sensor is that because of the construction, it is made out of a zirconia electrolyte ceramic chip. That stuff is very porous. It actually breathes by itself. And so whatever amounts of dust or soot or other sticky substances we allow to deposit on the sensor itself, it will immediately block all of the very small pores on the sensor, and it will not allow the sensor to breathe. And as a result, it will not do any measurement. So contamination is a very, very serious issue when it comes to NOx sensors. Next, we have coolant contamination. This is also quite a popular issue, and the most likely culprit for this is the EGR cooler. And we know that EGR stands for exhaust gas recirculation. The main purpose for this is to reduce the engine out NOx emissions, and it is done in a way as to take a little portion of the exhaust gas, cool it because it's very hot, and then reroute back into the engine intake so that it can be burnt for the second time. And this cooling of recirculating gases will most of the time be done by the intervention of engine coolant, and that will be done in the form of a heat exchanger. And this is a multiple component part. It will have its own gaskets, and these gaskets can fail, especially if we have been running the coolant at a insufficient level or insufficient fill. And that will leave parts of the cooler exposed to extreme heat. That will deform the components, it will destroy the gaskets, and then when we finally do top up the coolant, it will now leak through the destroyed gaskets. And as you can see from this diagram here, the first place, if the cooler gasket leaks, it will find its way back into the exhaust system, and we will therefore have coolant contamination. Now, this coolant will also deposit itself on the top face of the DPF substrate. Usually, we see that in the form of this white stains. And although the engine coolant will not spontaneously combust and melt holes in the DPF, it will, however, block the DPF, which will cause it to break, which will cause to force the coolant further down the system. And whenever the NOx sensor gets exposed to any sort of liquid, it will come in contact with the superheated 800 degrees Celsius red hot glowing ceramic chip, and that will instantly give it a heat shock by cooling where the droplet has touched the chip, and in that place it will crack instantly and it will fail instantly. So this is also quite an important part to keep in mind, that we need to look out for possible signs of contamination, not only engine oil, but also coolant. Forward. The third contaminant, which is really a quasi-contaminant because it's not foreign to the system, but the form of this contaminant is foreign to the system. And that is the DEF crystallization. We know that, for example, in order for the SCR catalysts to work, they need the addition of a DEF fluid that is injected into the system, that is thoroughly mixed with the exhaust gases, and then is entering the SCR catalyst as a mixture. And only then can the NOx conversion inside the catalyst take place. But there's certainly several modes of failure for this system. And we could be having a malfunctioning DEF heater because before injection, this stuff needs to be preheated. When it is preheated, it can evaporate more quickly and more efficiently. If it is not heated, it will tend not to evaporate, but to actually stick to the surfaces of the exhaust system. And after this sticking, it will start to crystallize. And this crystallization, we can see quite a few evidences here. For example, over the around the injector itself, it is this whitish, almost like flourish stuff that it's yeah, a definite giveaway. And further down in the system, usually what we will see is this is huge deposits and almost like rock formations inside the system made out of this white crystallic stuff. And this is actually not the worst of examples. Trust me, we have seen much worse cases actually coming back from the field. So why is this important? This is important because whenever we have crystallization happening in the system, that means that our DEF fluid is not evaporating, but it is sticking to the walls of the system. If it is not evaporating, it means that it cannot enter the SCR catalyst in sufficient amounts, and that means that SCR catalyst cannot convert any NOx. If the SCR catalyst cannot convert any NOx, you can guess what happens. We get an error to the NOx sensor because it is picking up levels of NOx concentrations which are improbable, right? But in all actuality, it is not malfunctioning. It is simply reading the actual situation in the system. So it is a sign that we should actually check for signs of crystallization. We should diagnose the problems, look for low DEF pressure, look for coolant leaking into the system. We should look for the quality of the DEF fluid or some other issues. So this is quite an important topic to cover. Okay. Moving forward, I already briefly explained about the DPFs and the possible failure modes as a result of contamination. But there is another failure mode for the DPFs, and that is neglect of replacement. And if the DPF is overused, if it is regenerated excessively, if it is even reconditioned excessively, so reused for too many times, what we will see is that as a result of aging, we will have these pinholes forming in the DPF. We will have local melted spots forming because of the regenerations. We will see some cracks forming. In either way, we can see that the DPF will fail because of these reasons. And if the DPF fails, it allows the soot or the particulate matter to get past itself, which it shouldn't allow under any conditions. And that, you guessed it, it then finds its way on the NOx sensor. The NOx sensor gets black with all of this stuff. Now the soot finds its way also inside the small pores of the zirconia electrolyte ceramics. It is blocking those pores, so preventing the sensor from breathing and therefore preventing from any useful measurements. And yeah, the possible culprits for this to look out for could be oil contamination, coolant contamination. It could be injectors that are overfueling as a result of some other issue. And it could simply be the fact that we have not replaced the DPF in time or reconditioned it. And we could also be having issues with a stock back pressure valve that is causing excessive levels of back pressure and excessive buildup of soot that is simply clogging the DPF prematurely. Okay. Here I have put up a simple table that is highlighting the systems that could be malfunctioning, highlighting the condition and the possible remedies. For example, if we are looking at the EGR system, we could have a coolant leak, and then what you want to do in this case is to pressure test the EGR cooler to make sure that the gasket is not failing and replace the gasket in case if it is failing. In the turbocharging system, we could have internal oil leak as a result of failed bearings, so you should replace both the bearings and the seals. If we are looking at the DPF, we could be having a broken or cracked DPF as a result of some contamination or simply overusage. We should be performing, however, the root cause analysis to find out was it contamination or simply overusage. If it's overusage, we replace the DPF and everything is fine. If it's a result of contamination, we must fix the issue first and then replace the DPF and replace the NOx sensor if necessary. If we are looking at DEF system, well, there the issue is, of course, the crystallization, but the solution might not be that simple because this system is quite complicated. We should be looking for a DEF heater, making sure that it's operating correctly, replace if necessary. We should do the same for the DEF injector. We should check if it is spraying correctly. We should make sure that the DEF pressure is good, so that it's actually enough pressure is reaching the injector and not causing it to spray incorrectly. We should make sure that the DEF quality is good, and we should regularly replace the DEF filter. When all of these things are done and no issues are found, are we free to replace the NOx sensor? Also, we could be seeing some issues with the hardware itself. For example, there could be internal air or water leak. Now, this is also considered a contaminant because it will upset the balance of the system. And the possible culprits for that could be some rusted spots or loose clamps, in which case we should look for these issues and replace the components or repair the system. So I hope it makes sense. And if it does, then that's enough about issues. Now I would like to tell you a little bit more what have we done to improve the situation and to improve actually our own sensor to cope with these issues in a better manner. And so one of the things that we have done in the latest gen sensors that we are now rolling out is an updated cover design. And this is the result of extensive research of CFD analysis and experimentation. That what we have managed to achieve is a better circulation, is a better protection against ingestion of dust and particulate matter, and also a more effective drain in case if we see condensate water accumulation inside the sensor. So all of these activities have now made our sensor better, much more resilient against contamination and condensation, and it has also improved the accuracy and response time because of the better circulation. We have also altered the heating strategy of these sensors. In the previous generation, we used something that's considered or called DC heating. So that means it's a continuous DC current that is being sent through the ceramic chip. The chip itself you can see right here in this image. So this is the zirconia electrolyte material. It's extremely hard, extremely brittle. And what will happen with the continuous DC heating is that as we continue to send DC current through the heater element, it will heat up and its electrical resistance will increase. As the electrical resistance increases, we get less current, which means that the heating rate is slower and the chip is steadily reaching its stable temperature, and then it just stays there. As it turns out, there is a better way to do this, and that is the pulse width modulation. And what we are doing, instead of continuous DC current, we are actually sending it in short bursts or short pulses. As it turns out, this is much more easy on the ceramic material, which means that it has increased longevity, but it also has a very nice side effect, is that because of these pulses that we are sending every set time interval, we also get a condition of electrical silence between these two pulses. And that means that we are able to do the actual measurement of the NOx concentration between these short pulses at the period of electrical silence, making us face less interference, less electrical noise, which is producing a much clearer and more accurate signal. And lastly, we have also managed to improve the programming inside the sensor. And why is that important? It's important because when you first start the engine, there will be something what could be referred to as a question and answer session going on between the ECU and the NOx sensor. And this is done in order for the ECU to try to detect a third-party NOx sensor. And the ECU will have, well, let's say 40 questions in its disposal that it knows it can ask the NOx sensor at any given time. Usually it will ask only 5 of these 40 questions, it will expect a reply from the sensor. If it likes that reply, it will then launch the operation and everything's fine. If the sensor doesn't say something, or if it says something that the ECU did not expect, it will launch a ghost code saying that a third-party sensor has been detected, and you will get an error, and you will be forced into the safe mode operation. And what we have done is that to ensure that this ghost code condition does not occur, we have taught our sensors, or we have loaded a programming into them that knows all of these 40 questions that the ECU can ask, because we know that as a result of software updates, sometimes the ECU will be instructed to ask different questions to the sensor, but still out of those 40. And so when reverse engineering these sensors, what we usually do is we install them on the truck, the original sensor we install on the truck, and then we listen for the communication between the ECU and the sensor. And in that communication, we will pick up these 5 questions. We'll pick up these 5 answers. Normally, we load that into the sensor and expect it to work properly. But as a result of software updates, now different 5 questions are coming, but we are not prepared for those, so we are having a ghost code issue. Now, the latest gen sensors come equipped with all the questions, all the answers, so this is no longer a serious issue. But in case if this does become an issue, well, let's say the original manufacturers find some way to throw our sensor off, then we now have the capability for our latest gen sensors to be reflashed in order to avoid a situation where we have a customer that has his stocks full of our sensors that are now deemed outdated because of some software updates. So we now have the possibility to actually reprogram them. Okay, and then in general, if we look back at what's been done to the sensor, we now have better waterproofing. We have better proofing against dust and debris. We are now running a better heating strategy, as a result of which there is a faster response time. There is also a more accurate operation because of the new heating strategy. And it now has more resilience towards software-related issues because of this question and answer session that I just explained to you. On top of that, our sensors now come with the ability to be reflashed. And yeah, so there's been a lot of updates that we've been working on to make our product stand out and to deliver a performance that is actually expected in the market. That's all from my side. In closure, I would like to state that please remember, we are not just another supplier. Our goal here is to bring value to our customers, and we would like to do that in terms by helping you before, during, and after the purchase. So please, if you have any questions, I'll be happy to answer them for you. I can see some are typing in the chat. So we have a question from Colin. When installing NOx sensors, is it okay to use a high heat anti-seize? Usually, with the NOx sensors that you're purchasing from us, we already have the proper anti-seize agent put on the sensor thread. So it is recommended not to remove that and using anything else. It's recommended to clean the bushing, to perhaps use some brake parts cleaner to make sure it is free of oils, and then simply place in our own NOx sensor that already has the anti-seize agent on it. I hope it answers your question. Then Sean Gnipper is asking, may I please have this presentation to train mechanics? Of course, I will leave my email here in the chat. Please feel free to reach out to me over email, and I will then send you the presentation. There we go. And also perhaps supplementing a little bit to the question that Colin asked, the reason why we specify and why our sensors come equipped with a specific kind of anti-seize agent is that we do not want the wrong stuff on the sensor head, not for the reason that it could get stuck, but for the reason that it might have incorrect chemical composition that could interfere with the readings of the NOx sensor, because the anti-seize agent is very close to the actual system, meaning that there is a chance that it might evaporate, and likelihood that the sensor will pick it up. And if it's composed out of aggressive chemicals, we could have an effect that it is poisoning the sensor, throwing off the readings, and making it inoperable. I hope it makes sense. Any more questions? Please do not be shy, guys. Because, yeah, somebody's asking to resend the email. Sure enough, just a second. Can you see it? I can see that another guest has just entered the meeting room. Unfortunately, the presentation is over. Trying to admit him. But it doesn't seem to be working. All right, in any case, whoever had come into the meeting and feeling that it was a little bit too late and perhaps you've missed some important information, I'll be holding another session just like this one today at a later time. Please look at the flyers that were sent out to you and feel free to join for the latest session if you find it necessary. So having said all that, if there's no more questions, I would like to thank you all for participating. I really value our commitment, our relationship, and I wish you a pleasant day.